Two hemispherical thin shells made of insulating materials are concentrically arranged in a free space as shown. The radii of the larger and the smaller spheres are capital R and small r, and they carry net positive charges capital Q and small q respectively. The charges are uniformly distributed over the surfaces of the shells. Find the force of electrostatic interaction between the shells. So there are two hemispherical shells placed like this, and we have to find the force between them. Okay, so this is a question, and this is a question from Pathfinder and hence from Olympiad. So we have two shells like this, and they carry charges, and we have to find force. So let's see how that can be done. Let the force between these two be F1. Now imagine the other half of this shell also is placed here, and the force between this larger hemisphere and this part of smaller hemisphere, this is imaginary part, this is not actually placed, is F2 suppose. So I'm taking just the same thing flipped horizontally, and now suppose we bring these two parts and join them like this. Then we have full sphere, and in which there is a smaller sphere. Now we know that a full sphere having uniform charge on its surface will produce electric field equal to 0 inside it. So there is no electric field here due to this full spherical shell. So since there is no electric field, so on every half part, on this part as well as on this part, net force should be 0 due to this outer shell. So F1 and F2, the summation of these two should be 0, the summation of these two should be 0. So this implies F1 should be equal to F2, first thing. Assume the charge density on outer shell to be sigma, and on the inner hemisphere, the charge given in the question is Q, and since we are adding the similar hemisphere, so the total charge becomes 2Q. So this 2Q will make electric field here, and that electric field will produce a force F1 plus F2 on hemisphere, outer hemisphere. So the electric field in this region due to the inner shell is E suppose. So the charge per unit area on this outer shell, which we call as pressure is sigma charge density into electric field. So this is the pressure. Electric field is K2Q by R square. On outer hemisphere, we have F1 plus F2 as resultant force. So that resultant force must be equal to pressure into area of projection. So the situation is like this: we have pressure, and this is the area of projection pi r square. So pressure into area of projection will give total force acting on this hemisphere. So that should be F1 plus F2. And since F1 and F2 are equal, so F1 plus F2 can be written as 2F1 sigma into K2Q by R square into area of projection, that is pi r square, the area of this projection. Put the value of sigma. Sigma is Q over 2 pi r square because Q is on a hemispherical surface. So that's area is 2 pi r square. This is the value of K, 1 over 4 pi epsilon naught 2Q into pi, and cancel this 2 and solve for F1. So this is the force F1 which we require to find in this question. Okay.